Imagine a factory floor where the machines aren't just, performing their assigned tasks, but are constantly learning, adapting, communicating with each other and with the broader enterprise systems, all without constant human intervention.
Yeah, picture production lines that can basically reconfigure themselves on demand.
Exactly. Predicting maintenance needs before a part fails, optimizing output in real time, what would that truly look like? And, maybe more critically, what are the architectural blueprints, the standards, that will actually get us there?
That's the core question, isn't it?
Today, we're diving headfirst into the very cutting edge of industrial automation. We've got the agenda and an overview from the upcoming IE International Conference on emerging technologies and factory automation, specifically their industry forum.
And this isn't just about small tweaks, is it? We're talking fundamental transformation.
Absolutely. Our mission for you, the listener, is to pull out the most impactful nuggets of knowledge from these documents. We're focusing on IEC 61499 in the industry and that really pivotal drive to bridge the, historically separate worlds of OT, operational technology, and IT, information technology.
Get ready for some serious insights because this stuff is shaping tomorrow's factories.
It really is.
And the critical element here, I think, is that we're not just talking about incremental improvements. This forum and the kind of focused discussions it's setting up, it represents a pretty significant paradigm shift.
A shift away
from the often rigid centralized control architectures that have dominated industrial automation for decades. We're moving towards something far more flexible, more distributed, and frankly, more intelligent.
And forums like this are where that happens.
They're absolutely crucial. They are the crucible, really, where theoretical concepts get tested against real-world demands, where practical application gets hammered out through collaboration. This is where the future of these complex industrial environments starts to take actual shape, translating that vision into, tangible strategies.
That's a powerful way to frame it. So, okay, let's dissect this. What exactly is this event that's signaling such a profound shift?
Right.
We're looking at the IE International Conference on Emerging Technologies and Factory Automation, or ETFA, Industry Forum. Now, the name itself, especially under the IE umbrella,
it carries weight.
It immediately tells us we're dealing with the front lines of tech innovation. Our sources pinpoint this event for September 10th, 2025, which gives it this fantastic immediacy, doesn't it? We're looking at what's being solidified for deployment, really soon.
In the very near future, yeah.
And the core theme, advancing industrial automation, and even more specifically, IEC 61499 in the industry.
That telegraphs it right there.
Yeah, exactly. It immediately signals the central focus of our deep dive, this international standard, IEC 61499, that many believe is poised to radically redefine how we automate.
And given IE's global stature, as the preeminent professional organization for electrical and electronics engineers, this ETFA Industry Forum isn't just another conference.
No.
Its existence and the really focused agenda around IEC 61499, it signals a critical inflection point. It means the technology has matured, beyond just academic concepts. It's ready for serious, widespread industrial adoption.
Okay, so ready for prime time.
Pretty much. And the Why Attend section in the sources offers some really compelling reasons that highlight this practical urgency. Attendees aren't just looking for abstract knowledge. They want to gain valuable insights into the current landscape of industrial automation. That implies understanding not just the what, but the where are we going next. They want to discover the latest technological advancements, the innovations that are production ready, not just, lab prototypes.
Things you can actually use now.
Exactly. And crucially, the forum promises practical guidance on integrating innovations into existing systems. Now, this is a huge, often underestimated challenge for anyone in the industry.
Oh, I can imagine. Brownfield versus greenfield.
Precisely. It's one thing to design a brand new site with all the latest tech. It's quite another to retrofit a sprawling factory that's maybe been running for 30 years with a patchwork of legacy systems.
Yeah. How do you integrate state-of-the-art flexible control with, say, PLCs from the 90s and old SCADA systems?
That practical guidance is gold. And finally, the forum actively aims to foster collaboration and knowledge exchange to drive the industrial sector forward. This is where that real cross-pollination happens, moving beyond individual company problems to shared industry solutions.
So it's an acknowledgement that nobody has all the answers.
Exactly. Collective intelligence is paramount here.
Okay, that makes sense.
Yeah.
The sources also talk about the different participants.
Right. And the diverse composition of participants really illuminates this collaborative approach and the the multifaceted nature of the challenge. You've got technology vendors naturally showcasing their latest technological solutions shaping the future.
They're bringing the new tools, software, smart devices, network gear.
Exactly. Then there are the end users, the industrial companies themselves. They're actively seeking ways to boost production efficiency, optimize supply chains, and maintain high drug manufacturing standards.
And that example of drug manufacturing is really potent, isn't it?
It really is. We're not just talking about general efficiency gains here. We're talking about precision, rigorous validation, compliance in an environment where even tiny deviations can have severe consequences.
For safety, for public health.
Absolutely. So how does a pharmaceutical giant ensure data integrity and real-time control to meet those super stringent regulatory requirements using these new standards? That's a high-stakes application.
No kidding. Then you've got the system integrators.
Yep, the crucial bridge between the vendors and the end users. They're looking for insights on seamless integration of automation technologies and sustainable industrial solutions. Their job is to make all these disparate systems actually talk to each other.
To architect reliable, future-proof solutions.
Right. To ensure that the promise of new technology actually translates into operational reality. They're the frontline problem solvers.
And we can't forget the startups.
Definitely not. They consistently bring innovative methods, simplify tech integration, enhance real-time monitoring, and drive AI automation. These agile companies, they're often the ones pushing the boundaries, right?
Yeah.
Introducing fresh perspectives, sometimes disruptive tech that can radically change how things are done.
And the format itself. A half-day event.
Yeah, half-day event based on invited presentations, which emphasizes a focused, expert-led discussion rather than, say, a broad general conference. This promises depth over breadth, focusing on critical topics with established thought leaders.
It really sounds like a comprehensive ecosystem converging, bringing together every critical stakeholder to not just talk about, but actively build the future of industrial automation.
Yeah, that's the idea.
And it's worth noting that Angela Trokich from universalautomation.org is listed as a key co-organizer. Her involvement immediately flags universalautomation.org as a central player in championing this new wave, doesn't it? Makes her importance for the discussions pretty clear. She's definitely at the heart of this movement.
Seems that way, yeah.
Okay, so building on that foundational understanding of the forum's mission, the agenda then dives straight into the crucial how, exploring the real-world experiences of companies actually deploying this technology.
Right, and practical.
The first main session, our sources indicate, is a panel titled IEC 61499 in Practice, Experience Exchange about implementing the technology. This is where the concepts move from white papers to actual factory floors.
Rubber meets the road time.
And again, Angela Trokich from universalautomation.org is moderating, further underscoring that organization's pivotal role in driving the standard forward. Now, for an audience like ours who are pretty knowledgeable, we can go beyond just a basic definition of IEC 61499.
Sure.
It isn't just distributed control. It introduces this event-driven paradigm for industrial systems, breaking free from the often rigid, sequential scan cycles of traditional PLCs, programmable logic controllers.
Yeah, that scan cycle limitation is a big one.
Think of function blocks, the core components of IEC 61499, almost like self-contained microservices, but for industrial control.
That's a good analogy.
Instead of one giant monolithic program, you have these independent, reusable blocks that communicate by sending and receiving events. This lets them react instantly to specific triggers or data changes, executing on any compliant device across the network.
So it's less like a single conductor leading an orchestra in strict time.
Right. More like individual virtuosos, coordinating seamlessly, on the fly, responding to cues from each other, regardless of where they're physically located on the factory floor.
Distributed intelligence.
This architectural approach makes automation systems far more flexible, adaptable, and just easier to modify. It's a radical departure from the traditional, hierarchical, often inflexible programming methods we've seen for years.
That analogy of microservices and virtuosos is incredibly apt. It really highlights the innovation here. And this raises an important question. Why is this experience exchange so vital for a standard like IEC 61499? Especially given its, architectural departure from the norm.
Because it's new and different.
Exactly. New standards always face a unique set of adoption challenges. Legacy system integration, workforce reskilling, it's a long list. Real-world success stories are great, but maybe even more importantly, candid discussions about the hurdles they overcame. That's incredibly effective in accelerating integration.
Learning from mistakes, basically.
Right. Or challenges, yeah. This panel seems designed to provide that critical shared learning, where the scars of early adoption can become blueprints for future success for others.
Okay, so looking at the panelists listed.
Yeah, the list tells us a lot about the breadth of perspectives and the specific challenges that will likely get dissected. We have Michael Massalo from AFRI, a major engineering and consulting company.
So the system integrator perspective again.
Right. Wrestling with those brownfield sites. They're not just designing pristine greenfield setups. They're often faced with that patchwork of legacy systems, old PLCs, proprietary SCADA, different field bus protocols.
All the fun stuff.
Exactly. Their insights would illuminate the real-world pain points of migrating existing control logic to an IEC 61409 framework, the challenges of coexistence, data mapping, maybe even the surprising benefits, like how modern standards can breathe new life into older hardware, extending its useful life and connectivity.
Interesting. Who else?
Then there's Zakaria Ben-Turki from Harmony System. Their focus, often on specific control system software and automation solutions, suggests they might get into the practicalities of toolchain adoption.
Like what software actually works best for development? Debugging.
Yeah, what development environments are working well? What are the debugging challenges in a distributed environment? That's not trivial. They could offer insights into optimizing function block design, maybe best practices for developing reusable libraries to speed up deployment.
Okay. And Federico Fumagalli from JW.
Potentially representing a component manufacturer or a specialized automation provider, they could offer a crucial perspective on modular hardware integration.
Oh, the physical layer.
Right. For IEC 61499 to really shine, the physical hardware needs to be just as flexible as the logical control. How are component manufacturers designing their devices, smart sensors, industrial PCs, to natively support IEC 61499 execution, ensuring robust, seamless interoperability from the ground up? That's key.
Makes sense. What about Kylan, Sam Wang?
Almost certainly focused on industrial networking and communication. This is critical, right? IEC 61499's distributed, event-driven nature relies heavily on robust, reliable, intelligent networks.
So questions like,
what network topologies best support this distributed control? How do you ensure real-time performance and determinism over standard Ethernet, especially with high data loads? And what about cybersecurity? That's huge when control functions are spread across the network instead of isolated in one box.
Yeah, cybersecurity keeps coming up.
As it should. Then, a particularly illuminating participant, Flemming Nergard-Andersen from Novo Nordisk.
The pharmaceutical giant, the end user.
Exactly. A fantastic example. Their insights would be absolutely invaluable on how IEC 61499 can be leveraged for maintaining high drug manufacturing standards.
Because the stakes are so high there.
Yeah. Totally. Precision, validation, compliance. They're not just important. They are non-negotiable legal and safety requirements. Novo Nordisk could discuss how IEC 61499 helps ensure data integrity, maybe simplifies validation processes, improves batch control, reduces human error, all directly impacting product quality and patient safety.
What tangible improvements did they actually see? That's what people want to know.
Precisely. Better auditability, better quality control, faster time to market for new drug formulations. That's gold standard proof.
And finally, Stephen Malty from Platinum.
Likely a software or integration services company. They'd probably share experiences around the human element of deployment.
Ah, the people side. Training, adoption.
Exactly. User adoption challenges, the necessary training programs for a workforce used to traditional PLC programming, maybe even the cultural shifts needed within an organization to really embrace a more modular, agile automation philosophy.
And the business case, ROI.
They might shed light on that too. Return on investment from reduced engineering time, maybe, increased system uptime, offering that solid business case for making this technological transition.
So putting it all together for this panel.
We can confidently speculate the practical discussions would cover everything from those initial hurdles navigating existing vendor relationships, the learning curve for engineers switching to event-driven thinking, maybe even internal resistance to change.
To celebrating the wins.
Absolutely. Concrete success stories. How did IEC 61499 lead to demonstrable improvements in efficiency? Significantly enhanced flexibility for production changes. Measurable cost reductions. They'd likely share invaluable best practices for integrating this tech into existing systems.
The gotchas.
Oh yeah, perhaps most importantly. What were the unexpected issues that cropped up? The debugging nightmares, the unforeseen interoperability quirks, and crucially, how are they successfully overcome? This panel directly addresses those why attend points we talked about earlier.
Providing that much-needed practical guidance on integrating innovations.
And empowering end users like Novo Nordisk to really boost production efficiency in those high-stakes environments. It's about learning directly from the pioneers who are already charting this course.
That's a truly detailed look at the practical application side. It highlights that for any new tech to get adopted widely, you absolutely have to confront these real-world challenges head-on and share the lessons learned. But let's play devil's advocate for a second.
Okay.
Where do these new systems, despite all the promise, still hit a wall? What are the unforeseen costs or the steepest learning curves that maybe aren't typically highlighted on a conference agenda? The kind of issues that make engineers tear their hair out?
That's a crucial question, definitely, because no technology is a silver bullet, right? The gotchas often revolve around that transition phase. For instance, the sheer effort of migrating existing complex control logic from proprietary PLC code to an IEC 61499 event-driven architecture can be immense.
It's not just copy-paste.
Not at all. It requires a complete rethinking of control philosophy. Engineers trained in sequential programming often struggle initially with the parallel distributed nature of function blocks. There's a significant investment needed in retraining the workforce. That's a real cost.
And interoperability.
Okay.
Even with standards.
Well, while IEC 61499 promotes interoperability, dealing with the actual edge cases, diverse hardware, different communication protocols from various vendors that can still present integration headaches. It often requires deep domain expertise and maybe even custom development work.
More unforeseen costs.
Could be. Longer initial deployment times than expected, extensive testing requirements for validation, especially in complex systems, and maybe needing new diagnostic tools because traditional troubleshooting methods aren't really equipped for these distributed systems. It's definitely a marathon, not a sprint for organizations making this shift.
That makes perfect sense. The human and integration challenges are often just as significant as the technical ones. Okay, so after a short networking break, the forum moves into what I find particularly compelling. Its second crucial discussion. This panel is titled Infrastructural Control Architecture, Bridging OT and IT through Open Standards, Modular Hardware, and IEC 61499 Enabled Control. Wow.
That title itself.
It's packed, isn't it? It's not just a string of buzzwords. It really encapsulates a massive fundamental architectural shift happening in industry right now. It signifies a profound reimagining of how factories are designed and operated.
Absolutely.
This panel is moderated by Franco Cavadini from G3N. His affiliation hints at maybe a practical, sustainable industry perspective driving these advancements.
Could be. And what's truly fascinating here is that core concept, bridging OT and IT. For years, these two realms didn't just exist in separate silos. There was often this historical chasm, right?
Yeah.
A deliberate separation driven by fundamentally different priorities.
Tell us more about that separation, OT versus IT.
Okay, so OT, operational technology. That's primarily the hardware and software that monitors and controls physical processes, devices, infrastructure, think robots on the assembly line, power grids, chemical reactors. Its absolute top concerns are real-time, deterministic control, reliability, and physical safety.
Stuff has to work reliably all the time.
Exactly. And historically, these systems were kept isolated, air-gapped even, from the broader corporate network because of these critical uptime and security requirements.
And IT.
IT, information technology, that deals more with the computing, storage, networking aspects of data for business processes. Think enterprise resource planning, ERP, cloud services, data analytics. Its priorities are more around flexibility, data management, connectivity across the organization.
So bridging them isn't just plugging in a cable.
Oh, far from it. It's a profound cultural and architectural challenge. You're integrating systems designed for entirely different purposes and risk profiles. And the really deep insight into this OT-IT bridge, it isn't just about enabling data flow, it's about fundamentally redefining decision-making authority on the factory floor.
How so?
By pushing intelligence and autonomy right to the edge in ways that were previously unimaginable. This creates a more resilient, self-optimizing system, but also, frankly, a significantly more complex security landscape that needs careful navigation.
Okay, so why is this bridge essential then? Why take the risk?
Because keeping these realms separate means huge missed opportunities. Connecting them unlocks massive potential. You get data-driven decisions by feeding real-time operational data into IT systems for advanced analytics.
Predictive maintenance, for example.
Exactly. Predictive maintenance with unparalleled accuracy. Monitoring machine health proactively to prevent costly, catastrophic breakdowns, not just reacting after they happen. It opens doors for remote control and diagnostics on a scale previously impossible, makes operations more flexible, more resilient.
Aligning with those event highlights.
Yeah.
Real-time monitoring and AI automation.
Precisely. Ultimately, it leads to overall operational intelligence and a real competitive advantage. Without this bridge, you simply can't achieve that level of smart, interconnected, truly autonomous factories that the industry is striving for.
Got it. So the panel title breaks down the pillars supporting this bridge. First, open standards.
Right. And for a knowledgeable audience like yours, the real shift isn't just about avoiding vendor lock-in, although that's a huge practical benefit.
What else is there?
It's about catalyzing an entirely new innovation ecosystem by democratizing the building blocks of industrial control. Open standards empower startups, research institutions, even end users themselves to contribute to and customize core logic.
So moving beyond the black box.
Exactly. Towards a collaborative, shared platform for the future. It fosters greater competition, drives down costs, and accelerates the pace of innovation across the entire industrial sector, much like open source software transformed the IT world, really.
Okay, pillar 2, modular hardware.
The advantages here are immense. It signifies moving away from those rigid, monolithic control cabinets towards a more adaptable, almost Lego-like approach.
Legos for the factory floor.
Kind of. It means you can upgrade or reconfigure specific components, a sensor, a processing unit, a communication module, without having to overhaul the entire system.
So if one part needs an update, or you need more processing power for a specific function,
You can just swap it out without bringing down the whole production line. This drastically simplifies maintenance, reduces downtime, allows for much greater scalability and flexibility. Companies can adapt their infrastructure much more agilely as their needs evolve, instead of being stuck with costly, hard-to-modify systems. It enables a much faster iteration cycle for factory upgrades.
makes sense. And the third pillar, central to our deep dive, IEC 61499 enabled control. How does it specifically facilitate this bridging?
Its event-driven, distributed nature is the absolute key. Remember those independent, reusable function blocks we talked about?
Yeah, the microservices.
Right, because they can be deployed across various devices on a network. IEC 61499 creates this remarkably flexible and resilient architecture. This allows for seamless integration of control functions across different devices and systems from the very edge, in the OT environment handling immediate physical processes, all the way up to IT applications doing data analytics or ERP.
So it spans the gap.
It forms a cohesive, unified architecture that truly spans both OT and IT. It enables data and control signals to flow seamlessly, securely, intelligently, making that smart, interconnected factory vision a tangible reality. It directly builds on the practical implementation discussions from the first panel, showing how that microservices concept extends right up to the enterprise level.
Okay, and the panelists for this session, another diverse group.
Absolutely, and bringing incredibly crucial perspectives. Marco Zampoli from Advantech, they're leaders in industrial computing and IoT. His insights would be invaluable on the hardware component.
How to make hardware tough enough for the factory floor, but also IT friendly.
Exactly. Robust enough for harsh environments, yet able to connect to the cloud, run complex AI at the edge, seamlessly integrate with enterprise networks. He'd likely discuss the critical role of edge intelligence processing data closer to the source to cut latency and bandwidth needs.
And Renata Pacheco Silva from Amiram.
Likely a solutions provider, focusing on practical integration and real-world applications of these new architectures. Their experience might highlight using digital twins to model and simulate these integrated systems first.
Optimize design, predict performance before you build.
Right. They could shed light on the challenges and successes of building those holistic end-to-end solutions that truly unify OT and IT operations.
Then David Puron from Barbara. You mentioned cybersecurity earlier.
Yes, and Barbara specializes in industrial cybersecurity and edge computing. His perspective would be absolutely vital on securing that OT-IT bridge.
Because connecting previously isolated systems opens up risks.
Huge risks. The attack surface expands dramatically. How do you protect against sophisticated cyber threats, ransomware, data theft, even nation-state attacks that could impact physical safety, production, data integrity. His insights would have to cover endpoint security, network segmentation, anomaly detection, ensuring the trustworthiness of data flowing between these critical domains. It's non-negotiable.
Definitely. Rudy Tienda from Penguin Solutions. High performance computing, AML.
Right. His role suggests how advanced analytics and artificial intelligence get seamlessly integrated into this new bridged architecture. This is where all that raw, high-volume data from the OT side gets transformed into actionable intelligence.
Driving that AI automation.
Exactly. He might discuss deploying ML models at the edge for real-time anomaly detection, predictive quality control, dynamic process optimization. He'd likely explore the necessary data pipelines, computing infrastructure, and the specific algorithms that make this intelligence possible.
And finally, Eugene Spiropoulos from Yokogawa, a big established player.
Right, a global leader in industrial automation and control. They provide the perspective of how a major company adopts and leverages these open standards and new architectures across diverse industries.
So large-scale integration challenges, reliability in critical infrastructure.
Exactly. Phased implementation strategies, balancing innovation with operational stability, the long-term vision for a fully integrated OT-IT future from a foundational vendor's viewpoint.
So bringing all these experts together.
It will undoubtedly extrapolate those benefits mentioned in the event highlights. Seamless integration of automation technologies is the direct outcome here, leading to sustainable industrial solutions through optimized resource use, less waste. It will significantly enhance real-time monitoring by making everything accessible, and crucially, drive AI automation by feeding rich data streams into intelligent algorithms.
It sounds like building the nervous system, the brain, and the immune system of the smart factory.
That's a great way to put it, all working in concert.
That paints an incredibly compelling picture of a deeply integrated future. But let's consider the flip side again, briefly. With such profound changes, especially connecting those previously isolated OT systems, what are some of the biggest vulnerabilities or maybe unintended consequences that might emerge from this OT-IT convergence, the stuff these experts really have to wrestle with?
That's precisely the kind of critical thinking this forum fosters, you'd hope. The primary vulnerability, as someone like David Piron would likely stress, is that dramatically expanded attack surface for cyber threats.
Right, the air gap is gone.
It is. Historically, OT systems benefited from that isolation. Connecting them introduces risks, ransomware, data exfiltration, even nation-state attacks targeting critical infrastructure. Ensuring robust, multi-layered cybersecurity, not just at the network edge, but deep within the OT environment, becomes absolutely paramount.
What else? Beyond security.
Well, another unintended consequence could just be the sheer complexity of managing such a diverse, distributed, interconnected system. Debugging issues might become way more challenging. Is the fault in the hardware, the software, the network, an interaction between domains that were previously separate?
Tricky to pin down.
Very. And the need for a highly skilled workforce that understands both OT and IT becomes even more acute. There's currently a significant talent gap there.
So a people challenge again.
Absolutely. And lastly, while open standards promote flexibility, ensuring true semantic interoperability, meaning devices from different vendors don't just communicate, but actually understand each other's data, in the same way that's an ongoing challenge. It requires robust standardization efforts and really diligent implementation. It's definitely a journey, not a destination, and careful navigation is key.
Okay, so what does this all mean then when we bring both panels together? We've looked at the practical application of IEC 61499 and this critical architectural shift bridging OT and IT. How do these discussions fundamentally change the landscape of industrial automation, moving beyond just incremental improvements? It seems clear the ultimate objective is truly transformative, advancing industrial automation towards capabilities far beyond what we think of as state-of-the-art today.
Yeah, if we connect this to the bigger picture, what we've seen discussed in this forum agenda paints a remarkably clear and I think decisive picture of the future of industry. The first undeniable trend is that accelerating shift towards openness and modularity in industrial control, driven fundamentally by standards like IEC 61499.
Moving away from proprietary lock-in.
Exactly. It's a deliberate strategic move away from those monolithic systems that historically locked users into specific vendors and limited their agility. It's about empowering end users with unprecedented choice, flexibility, the agility to innovate at speed, moving from being a captive audience to becoming active participants in a collaborative ecosystem.
Which should mean faster integration, lower costs over time.
That's the goal. Faster integration cycles significantly reduce total cost of ownership over the life cycle of industrial assets. Second, the imperative of integrating OT and IT. It's no longer a futuristic concept. It's a current, urgent, non-negotiable requirement for modern data-driven factories.
The engine of the next industrial revolution.
You could say that. The ability to seamlessly exchange information between the physical world of machines and the digital world of data analytics, cloud, business systems, that's what enables truly smart operations. Moving from reactive maintenance to predictive, from scheduled production to on-demand, from siloed decisions to holistic, enterprise-wide optimization.
And things like digital twins become more feasible.
Absolutely. This convergence allows for the creation of digital twins that can accurately simulate and optimize entire factory operations, pushing efficiencies to their absolute limits. And third, that collaborative effort, involving vendors, end users, system integrators, startups. It isn't just beneficial, it's absolutely essential for successful adoption and the sustained evolution of these technologies.
No single company can do it alone.
Exactly. No single entity has all the expertise or resources to drive such a monumental shift. Forums like ETFA highlight this ecosystem approach. Different players contribute their unique expertise, hardware innovation, software development, real-world deployment challenges, the disruptive spirit of startups to solve common challenges and collectively build a shared, more intelligent industrial future. Shared ownership accelerates problem-solving, ensures robust, well-tested solutions.
So if we look back at the event highlights through the lens of this deep dive,
we can see how directly these discussions address them, and with real depth. This forum shows how the latest technological solutions aren't just being presented. They're being rigorously debated, refined, shaped by the experts actually designing and implementing them in high-stakes environments.
and we see leaders actively trying to boost production efficiency and optimize supply chains.
By adopting these new approaches, leveraging real-time data, distributed control, making operations leaner, more responsive, that specific focus on maintaining high drug manufacturing standards using IEC 61499, it underscores the critical impact and the uncompromising demand for robust, reliable, compliant solutions in regulated sectors.
And simplifying integration, enhancing monitoring.
The detailed methods to simplify tech integration and enhance real-time monitoring are directly addressed by this shift towards open, modular, seamlessly bridged OTI systems. It's all about making the complex manageable, the disparate unified, and, the previously impossible, truly possible through intelligent architecture.
So this raises an important question for you, the listener.
Yeah.
What are the broader, maybe societal implications of these trends?
Yeah, think about it. We're talking about potentially more resilient supply chains that can adapt more quickly to global disruptions, ensuring the flow of essential goods. We're looking at significantly faster innovation cycles, new products going from concept to market much faster because manufacturing is more flexible.
More efficient use of resources, too. Sustainability.
Definitely. Reducing waste, energy consumption, leading to more sustainable industrial practices. And significantly, this will require and foster entirely new skill sets for the workforce. That blend of IT and OT expertise becomes crucial, creating exciting new career paths.
So it's not just about machines.
Not at all. It's about people, processes, and ultimately our global economy. These discussions hint at future possibilities where factories aren't just smart, but truly autonomous. Capable of self-diagnosis, self-optimization, self-reconfiguration, pushing us towards an entirely new era of intelligent manufacturing that responds dynamically to real-time demands.
Okay, let's bring this fascinating deep dive to a close then. We've really embarked on a detailed journey through the agenda of the IEETF Industry Forum, haven't we? Delving into the very heart of industrial automation's future.
We covered a lot of ground.
We explored the practical application of the IEC 61499 standard, understanding its event-driven, almost microservices-like power. And crucially, we've dissected that critical architectural shift needed to bridge the historically separate worlds of operational technology and information technology. The core nuggets of knowledge we've extracted really highlight the profound, undeniable importance of open standards, modular hardware, and the distributed control offered by IEC 61499 in shaping nothing less than the next generation of industrial efficiency and innovation.
And what's truly compelling here, I think, is how these seemingly highly technical discussions ultimately permeate and impact pretty much every aspect of our daily lives.
That's so.
Well, from the cost and availability of the goods we consume to the uncompromising quality and safety of the medicines we rely on, this quiet but profound revolution happening in industrial automation is building a more efficient, a more reliable, and ultimately a more connected world.
It's not just abstract theory in conference rooms.
Not at all. These are the foundational blocks for the products and services that underpin our modern society and drive global progress. So, maybe the next time you interact with a perfectly manufactured item, or even just think about the sheer efficiency of a global supply chain,
Yeah.
take a moment to consider how advancements like those discussed at forums such as ETFA are meticulously laying the groundwork for even more advanced systems, subtly but powerfully shaping your daily experience in ways you might not even realize.